Hi guys, my name is Rohan. I'm a software developer. I've worked at Theodor for like over 1 year. And yeah, today I wanted to take the opportunity to talk about how you'd be able to integrate BLE in your React Native apps. Kind of like the reason why I wanted to talk about this, and I'm kind of privileged that React Native have given the opportunity to talk about this, is that recently I've just come off a project that had a lot of involvement in terms of like BLE communication with an e-scooter app. So the app that we were working on was a companion app for an e-scooter. And the premise was that the client wanted us to have the app to connect to the scooter, extrapolate all the data and see all the statistics, such as like the battery health, the battery cycles, the potential range, and to be able to display all of that on the scooter itself. But as well as that, any settings that we were able to like set on the scooter, you should be able to do in the app. So we went through like a pretty big investigation phase to like figure out what's the best way to do this. And there's a lot of trouble with Expo, but we found like a pretty good solution. And I feel like the solution that we have, it's not really documented well anywhere else. So I thought it'd be a good idea to try and explain it to everyone here to see if it works or not. Cool. So first question I want to ask is, does anyone know the difference between BLE as opposed to conventional Bluetooth at all? Yeah?
One is low energy, the other isn't.
Oh, perfect. That's great. Nice. Yeah, if you know exactly what BLE stands for, then it basically answers the question. Yeah, so I've got some stats here. So yeah, Bluetooth low energy, yep, as the name stands, to conventional energy has just a much lower power consumption than conventional energy. Statistics-wise, it takes around like 0.01 to 0.5 watts compared to normal Bluetooth, and the latency is around 6 milliseconds compared to 100 milliseconds. However, the drawback, or like kind of like the use case for this is like you would get like a much shorter range in terms of connection. So that's kind of like what you're sacrificing. But in terms of like data transfer, you get like quite short bursts with very low latency compared to conventional Bluetooth. So yeah, bit of context of like what BLE is. But let's talk more about just BLE communication as a whole. So the way I like to break down the communication side of BLE is like 3 parts. So they've got the advertising part, the connecting part, and the data transfer part. So advertising mainly involves BLE devices, mainly called peripherals. And the peripherals here will be like the headphones, the heart rate monitor, and the e-scooter here. Their job would be to advertise the data that they have. And the data that would advertise was like the name of the device that they'd have, the manufacturing data they would have, as well as any other information that the manufacturer would want to add on there, so that the smartphone here, which would act as like the control, would see the data and decide whether it's useful to connect to this device or not. So that's part 1. Part 2 is that, so once the smartphone has the scan devices and has all the advertising data, then it can decide whether to connect to it or not. So in this case, the smartphone here decides to connect to the heart rate monitor, and the connection is pretty much quite simple. Asks to connect to it, and then job well done, it works. But then we go to part 3, which is the data transfer, which is probably the more complex part of the BLE communication. So let's keep with the example of like the smartphone and the heart rate monitor. So once we actually have the connection in place, we want to be able to have all the data that's provided with the heart rate monitor and to be able to send it to the smartphone itself. So if we had like an app that would track like the heart rate measurements provided by the heart rate monitor, we need to find a way with the connection that we have to get the data from here and send it straight to the app that we would be building. And so the process of data transfer is all dictated or defined by something called a GATT profile. GATT stands for General Attribute, and this is essentially just like a definition of how the data would be organized within the GATT server, which would be the heart rate monitor here, and defines like how the data is organized. In terms of the organization, I'll show you a diagram later on, but just a kind of like overview of like how the communication would work. It'd be similar to like a client-server model. So here we have a GATT client would be this smartphone here, and the GATT server would be the heart rate monitor. The client itself would request to get the heart rate measurement, and the server would send a response, successful or not. Let's say if it is successful, it would send off 60 BPM. But then going to like how the data would actually be organized, this is kind of like an abstraction of how the data in the GATT server would look like. So here, everything would be abstracted in something called a profile, in this case, the GATT profile. But then in here, we'd have like a collection of services. And inside the services, you have something called characteristics. The characteristics, I guess in the case of a heart rate monitor, would be like specific values that are provided by the heart rate. So we've got a real life example here. So this would be one service, and this would be another service. Oh, it's actually really blurry. Oh, wow. Okay, never mind. So service one would be like the general device information that we see here. So the general device would be like the model number string, manufacturer name string, system ID. Each of them would have like their own separate properties, like read, write, and notify. I think there's also like indicates as like an additional property, but there's mainly read, write, notify is like the main three ones that are looked at. And read, write, I want to say it's kind of self-explanatory. So like if you have a characteristic, if a client wants to read something, the property must be set to read. If a client tries to read a property that's set to like write, like the heart rate control point here, you'd get like a failure on the client side and it wouldn't get any data at all. So in terms of like how the client would interact, it needs to be very strict in terms of like the properties that would be defined here. So yeah, this is how it would look like in terms of like so this is how the GATT model will look like in like a real life example. And in the case of like a notify characteristic, so in the previous example, we have something here. For the second service, we've got something called the heart rates, and then we've got a property called notify here. And just to explain this a little bit more, the notify characteristic would work similar to like how a listener would work. So you'd have like some states. If the state changes at any point, then the new data would be actually sent to the client. So in this case, the smartphone would want to monitor the heart rates. Once it says it wants to monitor the heart rate, then the heart rate monitor would send off the heart rate measurement at that time. And if any updates are sent, or if any updates are made on the heart rate monitor, then it'll send that straight to the client, as long as the listener is still active, unless the client destroys it. Cool. So that's all the information that we have in terms of like the context to try and build the app. So how would we actually go about building an app? Well, there's three main considerations we have to think about. So if we want to have a smartphone or like the smartphone app to be able to like communicate with a BLE device, we need the smartphone to like act as the central to scan for devices. So that'll be one feature to scan them. And then once it scans, pick one of the devices to connect to them. Once connection occurs, it needs to see all the devices that are available, all the services and the values that are available. And then based on the service that you can, the smartphone app needs to be able to perform the actions such as like reading, writing, and subscribing to the notifications as applied by the characteristics. Cool. So how did we go about creating our previous app? So a lot of like the boilerplate or like the template of like how we would build it, I will be discussing here. So like the main thing we used here was Expo. Much better than Create Native App. Who is familiar or who isn't familiar with Expo? I guess who is familiar actually? Okay, so like around half the people. Okay, so if you're not familiar with Expo, it's basically an open source package that provides just like a bundle of tools that just makes building the app and distributing the app much easier, as opposed to just using Create React Native App, which means that you have to manage all of the native modules manually, which means you have like a lot more control. But with Expo, you kind of like abstract that part. You kind of create a managed workflow, which means that all of the native parts of creating a mobile app is managed by Expo, so you don't have to think about that. So that's why we kind of like Expo here. Just gives us a lot less to think about. In terms of actually providing the Bluetooth features of the smartphone app, we need to have a package. And the package that we mainly use is React Native BLE PLX. This is pretty good because it provides like pretty good TypeScript supports. It provides us all the main features to like scan for devices and connect to devices, as well as like providing all the like pretty cool listeners for like managing like state change for like Bluetooth. So like if your smartphone's Bluetooth state is off, or if it's resetting, you can provide some like callbacks to be able to like handle that kind of state and have some like extra like powerful functionality on your app if you need to have it. But I'm quite aware there's also another alternative, which is the React Native BLE Manager. I've not really had that much exposure with this, so I can't really say if it's better or worse. But I know that a lot of the features especially in the GitHub repo for this, it talks a lot about like some missing features. There are a lot of them are covered in by BLE Manager, and one cool feature that it provides is bonding. And the idea of bonding is that it's like another level of a connection. So if the smartphone app that we have and the heart rate monitor, like if we still use that example, if we want to connect our phone to the heart rate monitor, the information from the heart rate monitor will be saved locally on our phone, and then once that happens and the two devices get disconnected or just lose connection via like long distance range, then anytime they're like back in the same range, then they'd automatically connect. So that provides like another like kind of abstraction here, whereas in PLX you'd have to like programmatically add that kind of feature in, which is a little bit of a pain, but in terms of just getting started with like Bluetooth features, it's probably the best option at the moment. Cool. So this kind of like goes into like kind of the big pain points that we found in my previous project, where we found a lot of blogs that talked about implementing Bluetooth in their smartphones, but they wanted us to eject Expo. And for all of you who don't know like what that means, that just means that from the managed workflow that I have, where Expo kind of manages all the native stuff that we don't have to manage, we'd have to kind of get rid of all that kind of management that Expo has, and we'd have to end up with like a bare React Native app where all of the native modules would be managed by us in particular, which is a bit of a pain because we started the project adding Expo in, and the Bluetooth was the first thing we worked on, and to find out we had to eject Expo was just not convenient whatsoever. So we had to find a different solution because it just meant like we just installed a package that we just didn't need to use in the first place. So up came the holy grail, which was the Expo plugins or Expo config plugins that are provided by Expo on their repos. And what these are essentially are just a way of adding like custom native modules into your application without needing to eject Expo. The only caveat is that you can't use the Expo Go app, which is just an app to like test your React Native apps without having to build them locally. So instead, the alternative solution is to do pre-builds on your app or create like a development build, which is the solution that we went along because it's just easier to distribute to other developers who are like working from home, working like in like a long distance. So yeah, that's kind of like the big things that we found that weren't really documented anywhere. So like the config plugins really saved us in terms of ejecting Expo, and that's why we kind of recommend this workflow to work with. Cool. And the last thing I'd recommend is a service called LightBlue in terms of testing BLE devices. So what LightBlue provides to us as developers is if you, let's say on a project you are actually working with, well, we have to implement the Bluetooth pretty quickly, but you don't have the actual hardware to work with in the first place, you'll need something in place to kind of simulate the scanning, the features, and the connections there before you even have the hardware in place. So what we found is a pretty good, so with LightBlue, it's a pretty good service that is available on the App Store and the Google Play Store. So you can install it on your phones. You can also install it on your MacBooks. I don't know about Windows, but yeah, I'm not too sure about that. I'm sorry about that. But yeah, in terms of for Mac and like for mobile phones, it's pretty good because it can provide some virtual devices already provided by LightBlue. So in this case, we've got like a heart rate service that's provided by LightBlue, which is where the previous examples for the services and the characteristics came from, because it all came from here. And it kind of emulates how the heart rate would work. But as well as that, if you like click the tick option there, it turns it on and starts advertising the data so that when you start developing and you don't have the hardware there, you can just start working with this virtual device, connect to it, and then work with the services there. So it's quite easy to work with, and it's quite nice to work with until you actually have like physical hardware with you that actually have Bluetooth. Cool. So now, oh wow, that's really blurry. Thanks about that. Okay. So now we go into the coding aspect of it and delving a little bit more into React Native BLE PLX. Our entry point into going into like having the features of BLE is through this class called New BLE Manager. So with BLE Manager, it'll provide all the features for like scanning, connecting to devices, disconnecting to devices, stopping scanning, and then all the listeners that we want to have. within our application if we want that extra functionality. And then once we initialize this, then your code will, all you have to do is just access the manager that you've initialized, that you've created an instance from, and then from there you'll be able to like work with all the features there. Cool, and then that's as we say here, like once you instantiate the class, they can start running the start device scan, and it takes them some parameters, which you can, the first two you can set to null, and the listener you can provide yourself, and the listener itself will just be a callback that takes in like an error and a scan device. So the way the scanning works is it'll scan one device each and run the callback for that one device. So as you go through each device, you can add them to like an array and store them somewhere that you want. And then afterwards, once you stop scanning devices, you can just split them out to like a screen that you want to show them on. And overall, this is what the code would look like if you have it all working. So this is an example code I have. So just to quickly pause it there. So once we click that button, it runs the start device scan feature. And then once that runs, it runs for around 3 seconds, and then it calls the stop device scan function provided by the BLE manager. And then after that, it should spit out all the devices that we have here. That says heart rate. If you can't read it, did not expect that. So yeah, so from there, we've managed to do all the advertising part of our application. So part one that we mentioned before, sorted on this part. I'll quickly show you the code just to be able to explain it a little bit more of like how it works. So this is this is the application I showed in the video. So here, we initialize our manager up here. So we've got constant manager, which is Blue and UID BLE manager. I've encapsulated everything in a context just to be able to like have all the Bluetooth features just very much like within the same space. And then we have like functions for start device scanning. And then we call manager.startDeviceScan, and then null as like the optional parameters. But then this is the important part, which is the callback, which takes in the error and the scan device that the manager picks up. And then from there, we just apply some, like we throw the errors if there is anything. Otherwise, we provide some like filtering to see if this scan device is actually a provided object with some useful information, or whether if it appears more than once. Because with a BLE PLX, especially for Android, which is a bit of a pain, it can't handle like just handling duplicates, but it can do it pretty well on iOS, which is really annoying as an iOS user. So we have to keep on adding like this extra code, but yeah, we just have to manage with that. And then this is the second part of the code where we call the stop device scan function here, and that just returns all the scan devices that we have here. Does that make sense to everyone? I'm seeing some nods. Okay, yeah, that's good. Cool. So if I move on, so now it comes to just connecting to the device. So again, kind of just going over the code that is available there. So we've got connect to device, which is provided, which can be called by the manager, but this can also be called by the scan device that you like save. So there's like 2 versions of each of the functions that you can have. So you can have like connect to device, which where you specify like a device ID, and then there's some scanning options, which we won't really talk about at the moment. But if you want to connect to the device, but having like the actual device object available, then you can call just scan device.connect, and you don't need to pass any IDs, it just automatically connects it. It's the same thing for disconnecting to a device, where you have like a function for the manager, or you can have also a function for the connected device. I don't think there's any benefits or drawback for using either of the 2. I've just used manager just because I like to work at the top level. But yeah, it's open for debate on that part. And yeah, once you add those 2 functions in, then you'd expect to see something like this. So you'd see the scanning part from the previous, then we have heart rates here, and then we connect to the device. And then once we do that, then we can actually see the screen to, oh wow, that's quick. So once we see that, then we see the heart rate information here, and then we have the option to disconnect from the device down here, which will run the on-device disconnect function here. And how that will look on the code itself too, if I comment it out here, will look like this. So we've got a connected device here, which calls manager.connectToDevice. If this is successful, it'll return the device it's trying to connect, and then we just save that in states. And then if any errors occur, then we just throw the errors. And it's similar to disconnecting to the device, which is everything down here. Where, yep, similar. So this is like the example where you can either call the manager or the connected device. So we call the connected device directly here, and then we cancel the connection directly. And then once that happens, then we just set all the states to undefined here. But okay, but ignore all of this. We'll cover this pretty soon. Cool. Cool. So now that covers part 2, which is the connecting part of the BLE communication. So now it comes to more of the tricky section, which is the data. As we mentioned, we have like the GATT model, which kind of dictates like how the services and characteristics are organized. But before that, there's a bit of a process where that GATT client, once connected to the smartphone, when it's connected to the heart rate monitor, it's already provided that connection, but it doesn't really know anything that this heart rate provides. If you yourself kind of know what services are available and you want to directly just access them, you'll find yourself, like especially with the BLE PLX, you'll find yourself like throwing an error saying like this service or this characteristic or this value is just not discovered yet. So there's a kind of like a process before you need to actually access the values called discovery. And what that means is that the smartphone here needs to first request the heart rate monitor to just show all the devices, show all the services and the values that it provides. And then once that happens, then it'll just make everything essentially like unprotected and readable. So once that happens, you are able to call these functions here to just return all the services that the connected device has, as well as all the characteristics that it has. So then, otherwise before, it'll just throw an error saying it's just not discovered at all. So that's kind of like an important thing. But the way you discover them is through this function called discover all services and characteristics. And this is done in the codebase in the connected device here. Or not, okay, never mind. It is done here and discover device services. So here's just a callback that calls connected device dot discover all services and characteristics. Where this is used is down here in this use effects here. So every time the user will connect to a device, it'll run this function down here to discover all the services and characteristics. And then once that happens, we have like another function here to actually read some of the characteristics. So this is a prerequisite for this. If you just have that, you will get an error here, similar to what we said before. So you need to have this before you have to do everything else. Cool. Nice. Yeah, and just going back to what we said before on LightBlue, it's good to know if you're like actually working on a project that's trying to integrate BLE PLXs, knowing what the services would be and what the characteristics would be. Otherwise, you're kind of guessing what's there, and you'd have to interrogate the information for quite a long time. And the data that's returned through like the service function and the characteristic function is, the object itself is quite huge and it's got a lot of data. So if you already know like what like UUIDs for like each of the services, then it's already like saved you some time in terms of like trying to investigate what they would be and trying to manually connect to like each of the services. So that having like a good idea of that would be pretty good. In particular, if you're using LightBlue, one of the big drawbacks is that the UUIDs are actually stored as hex. Meanwhile, if you actually output them in React Native BLE PLX, it comes out in the UUID format. I've got the example here. So this is what you see in LightBlue, but this is actually how it would look like if you like console logged it. So the way I figured out how to like see if it's the right thing is just literally just find like pattern matching here, and that's how you know you've got the right service. It's a little bit annoying, but it's good to know there's some kind of like confidence that this is actually working. Yeah, that's just a one big note just to let you know if you're actually going to work on this. Cool. And then we go to the important parts, which is like reading characteristics, writing characteristics, and notifying. I'm kind of cautious for time. How are we doing for time? Sorry, don't me put on the spot there. Cool. All right, cool. Yeah, so I'll kind of just go over more of like the the demo examples than the code, but I'll go over the code afterwards. So yeah, for reading characteristics, similar to what we said before, you've got so this function can be called from the connector device, but you need to have these two first arguments as a prerequisite. So you need to specify the service ID of what you want to access and the characteristic ID of the value that we want within the service ID. So if you like go back to like this previous example, if you have, so let's say we want to access something like let's say like the model number string here, we'd want to know what the ID is for this, but then we also need to provide the service ID for this, and adds like a lot of like protection so that we're accessing the right thing and making sure that we're getting the right thing that we want, or the client gets the right thing that we want here. So yeah, having that, so providing that kind of like, providing these values will then return the characteristic object as a whole, but then with that characteristic, you just need to abstract the object, which is like, which is just through a dot value attribute access. But yeah, once you actually implement that, you will get something like this, where we use the same example here. So in the demo that I'll show you, we're accessing the model number string here, and we're outputting it on the screen where you connect to the device. So here, I'll show you the code, not the code, the video. We scan for devices. Oh, I'll skip this part. We connect to the device, and then because the characteristics themselves are returning promises, you'd have to wait for a while for the actual value to be returned. So here it kind of takes a few seconds for it to actually load. So here it says no model number found, but then give some time, it comes out as MacBook Pro 17. Cool. Yeah, and the reason why it comes as MacBook Pro is because I'm running on LightBlue, so it uses just the model number of the device I'm using here as proxy. Cool. Okay, and then quickly going into monitoring characteristic. This is a bit different to, it's a little bit different to how reading would work. So you'd still provide the service, you provide the characteristic, but for every like change of the characteristic, you need to have like a callback to be able to handle the changes. And if you want to like store it somewhere, then you do it within this listener, and then whatever the value is stored, you just return it to the screen that you want. I have the code here. If I go back to the example I used, so the video I'll show you here is where we're accessing this heart rate measurement, which is of a property notify. So every time it updates in the code, then it should just spit that value out on the screen. But I will warn you that the LightBlue one for the heart rate measurement is pretty shit. So like, actually you really can't see that, can you? That says 78, so that's like the initial value, but it doesn't frequently update. Oh wow, that's completely cut. Okay, that says, and now it's updated to 3, but yeah, you can just about see it. Yeah, it really was. Yeah, I didn't expect this. So like, once like the value changes from like 78 to 3, then it'll actually show the value here. You can't see it, but that's what is happening at the moment there. So that's a good example of how notifications work there. And then the last example is writing. The writing aspect means that you can send some values in the characteristics that's providing the heart rate monitor, but you actually can't see if the value is updated unless there's a read property somewhere. In this case, we have like, if I go all the way back, trying to access, this is the only write property that we have here for the heart rate control point, and there's no like corresponding value here, so all I can do is just write and trust that it's updated, which is exactly what I will just show you. So it's just more like, trust me bro here in this one. Wait, hold on. Cool, yeah. So yeah, got text input, type in hello. I really don't know what to input in control point. I don't know what that is. And then it's set. Trust me, it works. Cool. And that's all 3 BLE communication aspects that we've covered there. Cool. So now what are we left with? So now we've got an Expo app that's built with either like pre-built or with a development build, but it uses an Expo a config plugin for React Native BLE PLX, but with it, it's got functionality like scan for devices, stop scanning for devices, disconnecting, connecting to devices, as well as like reading and maybe writing to characteristics, especially for this heart rate monitor. And yeah, I hope that was informational at some point, and happy coding.
On one of your slides, it said that the phone was a GATT client and the device was a GATT server. And I wanted to know, like, what is that and why did you choose that protocol? Did you have a choice of different protocols? Is that the most common or?
Cool. Yeah, that's a good question. I'll go back to that slide just so we know what we're talking about. So yeah, you mentioned what is the so why do we use the GATT client here? So yeah, what it means for it to be a client and server. So the client is literally just the device within these two devices, like within this model that actually just requests for the data. Let's say in this case, the heart rate monitor actually wants to get some data from the smartphone, then the roles would actually reverse, and this would be the client itself because it's requesting the data here. So similar to like a client-server model in like networking, it's kind of the same situation here. In terms of do we have a choice with GATT, I believe with BLE, GATT is the mainstream choice, and we as developers didn't have an option to switch to it. It's mainly on the manufacturer side who build the BLE chip that provide like the advertising that kind of dictates how the data is like stored or like contained. Yeah.
How painful was it not being able to use Expo Go, and did you do anything to speed up builds and testing?
I can't really say like how painful it was to not use Expo Go. I've never really used it like in a professional sense. Like my first exposure to React Native is with just development builds or with pre-build. And personally, I thought it was fine. It's just more understanding like what it meant in the background, because I thought with a development build, you're literally just building the app to like similar to like a production app, but it's literally just building another Expo Go app. It's just you don't get the Expo logo on there. And your second question was like, what was it? How the development?
Speed up builds and testing.
Speed up builds and testing. Yeah. So you usually for development builds, you just need to run it once if you just need to add like one package with some extra native modules that's not supported from Expo. But if you have like another package that needs to be added and you need to rebuild the app to get that information, then you would go through some pain points of like waiting for like maybe 5-10 minutes to like an hour. I think we had the worst experience with iOS because I think a lot of developers were using development builds for iOS builds, so you had to wait. We'd be stuck in like queues, so we wouldn't even get to the point where like the build would start. We'd be stuck in queues for like maybe like 7 hours, and then once it was, and that would like end probably like at 3 o'clock in the morning, and then from there we'd find like our build working. But this is like a rare case where if you're like minimal like Expo modules that you want to import, then it's fine. But if you have loads, then you will have this pain. I don't really know how to improve the speed personally because we never really had to because it's not a big pain point. But yeah, good luck to whoever needs to.
Yeah, I apologize for earlier. Great talk. You mentioned that UIDs can be stored, so you could look them up, like prior, so you wouldn't have to request the services. Does that mean multiple devices can share the same UIDs for their services and you wouldn't have to look them up, or is that not?
You mean like storing the IDs? You mean like with the LightBlue service that I showed?
So, for example, you have 3 heart rate monitors, 3 people own them. They're all connected to the same device. Do they have the same UIDs for the same services that they provide?
I believe so, yes. So like if you have 3 smartphone devices connected to one thing, it would be the same thing. But I don't know if you can manually change the UIDs. With the LightBlue example, because that was a fake device, that was a virtual device, you're able to manually change it. But then when we were developing for our app for the e-scooter, and we used LightBlue to like interrogate the information to see what the services were, I tried to see if there was like an option to like actually edit the service IDs to just make it more readable, but there wasn't. So it's more like available for like virtual devices.
So just to clarify, for example, three e-scooters would have different UIDs for the same services, or they would have the same ID?
Yeah, 3 different ones, they would have like different UIDs.
Yeah, just a couple of questions. You mentioned about brute forcing and if you don't have the UUIDs. So I'd like to know if there's any experience of that and how painful it was. And secondly, probably more pointedly, is testing. So for example, how will you handle testing this at scale? So for example, with real devices, do end-to-end testing? Are you doing manual testing? How would that look?
That is an interesting question. I had a feeling this would come up. When we were testing when we were like building our app for our device, we spent a very long time for like a prototype to come in. But when it came to testing, we found that our prototype didn't even have all the features ready. So in terms of testing, we were essentially just mocking the data with Jest, but in terms of actually seeing if the data would change on it, we couldn't see that happen. So in terms of testing, I really can't give like a good example because we did not have the experience. But that's more of like it's more of like a bottleneck on the manufacturer, and that's kind of like the risk that we take for creating these kind of apps. But yeah, the way we kind of counteract it is like we did as much as we could on Jest testing. So we'd have the context there, and then have like a different hook to just extrapolate all the data that we had documentation also so like sometimes the information stored in Bluetooth devices they're not as like simple as like having values stored to them. Sometimes it's just like a huge like byte string. This is what we found. And we had like a copy of like what that would look like. So we kind of like took that structure, put that in our tests, and every time it changed, every time like some bytes changed like in our testing, then we just test if like those values changed. But in terms of like, actually seeing the change on the scooter, we didn't see it.
Great talk, thank you. I wondered if you did any like kind of like charting or like real-time kind of visualizing of any of the data.
Yeah, we did. So like for the stuff that did work, we just had like information on, I'm trying to remember now actually. No, actually, no, I don't think we charted anything like directly from the scooter data. It's just like we took some of the scooter data and took some like aggregations and stored in the back end, and then we pulled it from there, but nothing like directly from there, sadly.
You mentioned that it took a long time for prototypes to come in, and you were testing with like virtual data before that. Were there any pitfalls when you kind of got your first devices and you were trying to use code that you tested on virtual stuff on real devices?
Yeah, the main thing was the manufacturing company just adding more features onto the chip, so more characteristics, more characteristics. We just worked with one service which had like all the bulk of information. So the main issue we had is like we had documentation saying like where we'd find each piece of information, but then they'd add maybe like more on some sections and probably remove some. So it's just more of a pain like finding out where they were. Yeah, I mean, the best fix for that is probably just like for us, we just had constant communication with the client because he was mainly on our side and he was working separately with the manufacturers. So he was like, every time we had like an issue, we talked to him and then he'd like clarify it with us and then send us like more documentation. So nothing really on a developer's point to like fix that, but just more like, I guess, project scale. If you have like communication with the client, just make sure to always have that communication and keep them informed on that. And they can probably help you with that.
Hey, what kind of security considerations are there with connecting to a BLE device? Like what's to stop me from writing an app that can start writing to those e-scooters?
You mean just like modifying like the information?
Yeah, if you're saying that your app could be used to modify the settings of the scooter, what's to stop a malicious actor from doing the same thing?
That is a good point. So like as I mentioned, like some of the characteristics they'd have like the properties set to like either like read, write, notify, sometimes a combination of all. It's mainly like on the manufacturer side to like set like appropriate levels of like access. So if it's only write for like some values, then you'd expect that value to have like it's supposed to be written. So even if you as like let's say like with my heart rate monitor, if you like connect to it and you can only access the control points because that's the only thing that's meant to be written, then that in terms of security it's fine. But that's kind of like dangerous because you're kind of assuming that the manufacturer is safe. So it's yeah, the security can only come from like the manufacturer side. I don't really know what you could do on the dev side because I've not really had that kind of thoughts. But yeah, that's kind of like my thinking on that.
One from my end. So maybe the scooter one isn't a good example, but the heart rate is like a prime example where it's the type of monitor that you probably leave running in the background. Did you face any issues or difficulties when you were handling background activity with your React Native app and like the connection between the phone and the BLE?
No, not really. So if I go back to the Expo config plugin, when you actually install the plugin itself, like this here, I kind of cropped out the last part of it, but there's additional configs, so you can add like an extra object to the end of it to like configure the background scanning or background connections if you need to. So I set that as to true, and every time we like put the app in the background and then we come back onto it, we still found that the device is still connected. So I think, yeah, I mean, we added that configuration at the start, so we didn't really have to like think about it as like a worry at the end. But yeah, once we sort that out, then it's pretty good.
Yeah, great talk. I remember that BLE is all like 7-8 years now, and it starts with the beacons and the promise that we'll have a very great shopping experience with beacons, right? Which didn't happen because Amazon happened. And but seriously, I mean, is there a serious use case? Because right now it's like Bluetooth with, well, low energy, but it's still like Bluetooth. But there are some specifics on the BLE, like the proximity, which, well, it's not used at all here, right? How close are you from the heart rate, or how close are you from the scooter or whatever, which makes more sense. So what's a serious use case, or without, well, breaching any NDA, of course?
Oh, wow, that's a really good question. From what I've like researched in like preparation for this talk, a lot of the use cases I've seen is if you need like, I can't really think of like specific examples, but it's like because it's such a like a low power network and with like, such a short range, a lot of like IoT cases came up. I think in particular, like I think some smart home devices were like one of the examples I saw where if you want to have like BLE communication, but on the manufacturing side, you want to have like cheaper costs in terms of like powering it. That's one of the cases where you just want to have all the devices interconnected and you'd still have them in a pretty short range.